Welcome, my name is Deko Mohammed. So today I want to focus on the mole chemistry. But before, remember, if you are not subscribed, please subscribe so that you enjoy more free lessons. So under the mole, first we want to begin with the empirical formula, the molecular formula, how to derive them before we go to the concentrations. Now for us to know that, the simplest formula you have to know that, like we have here, let's say I'm having here the molar mass. Sorry, let's say I'm having here the mass. Then here I'm having the molar mass. Here I'm having number of moles. So see, for us to get the number of moles, we take mass over the molar mass. So number of moles is equal to mass over molar mass. For us to get the molar mass, we take mass over number of moles. Then, for us to get the mass is equal to molar mass times number of moles. But our main concern will be here for today's case, how to get the number of moles in trying to get the empirical formula. We take the mass over the molar mass. The molar mass is the same with RFM, so there's no problem, still the same. Now I want to write a simple illustration here. So you can see the percentage composition, the machine composition by mass of an oxide of iron is 70% is 70% iron and 30% oxygen. Determine it is empirical formula. Determine it is empirical formula. Determine its empirical formula. Then you are told bracket F is equal to 56 or is equal to 16. So we want to get the empirical formula for this. What you have to know, this percentage at the mass, they represent the mass. So for us here, the number of moles is the mass over the molar mass. So percentage represents the mass. But before that, there is a criteria of which the EMF is shown. So we begin with the element right here. The element we write iron is Fe. Then we have oxygen, O. Then after the element, we go to the percentage composition. Right here, percentage composition. The percentage composition of iron is 70. Obvious oxygen should be 30 because they should add up to 100. Even if it was not given, you should say 100 minus 70 because percentage is always 100%. Then after we write the percentage composition, remember this represents our mass. Next is to get now the molar mass. This one we can say RFM. It is given in the question. Iron is 56. Then oxygen is 16. After you have written the molar mass and the percentage composition, now we get the number of moles. We get the number of moles. Number of moles. For us to get the number of moles, we take mass over RFM. 70 over 56. The same with this, 30 over 16. So this will give me 70 divided by 56, 1.25, then 30 divided by 16. I'm getting 1.875. Next, we get the mole ratio. The mole ratio. The mole ratio. You see, 1.2 and 1.8. We take the smallest, then we divide with each. So the smallest here between 1.2 and 1.8 is 1.2. So we take over 1.25 or 1.25. It means here we get, I can show it down so that you don't confuse. You can say 1.25 over 1.25, 1.875 over 1.25, 1.875 divided by 1.25, I'm getting 1.5. Remember, this is not a whole number. For you to get a whole number, multiply with the smallest. So if we multiply by 2, we'll get 3. That means this is also multiplied by 2 so that it is the same. 1 by 2 will have 2. 1.5 by 2 will get 3. So the ratio is 2 to 3. So you can write down here, iron 2, oxygen 3. That's the empirical formula for this. We take the element, then we write the percentage composition, which is our case represent the mass. Some question they may give you the mass in grams, so you write the mass. Here you don't write percentage, you just write mass. But here we have been given the percentage composition, so we use that, which can be represent our mass. Then we go for molar mass, which are normally given in the equation. This is molar mass is normally given in the equation. Then the number of moles, we take the mass over the molar mass. Then mole ratio, then you write the formula. That's as simple as like that. I went through another empirical formula. Write it this side. Illustration number 2. You can say example 2. We are told an oxide of silicon was found to contain 47% by mass of silicon. By mass of silicon, what is the empirical formula? What is the empirical formula of the oxide? So we are told Si is equal to 28, O is 16, O is equal to 16. So an oxide of silicon was found to contain 47% by mass of silicon. What is the empirical formula of the oxide? So it means we first start with the element, the same with that element. Let's have the element here. Remember, we have silicon and we have oxygen. After the element, we write the percentage composition. Silicon, we are told, is 47. Oxygen, you take 100 because percentage is always normally 100%. So you take 100 minus 47, which gives you 53. Now we write the molar mass. Molar mass is given in the equation. Si is 28, O is 16. Then we get the number of moles. Number of moles by taking the mass over RFM, or the molar mass. 47 by 28, 53 by 16. If I take 47 divided by 28, I'm getting to the nearest whole number is 1. To the nearest two decimal places, is 1.68. Then 53 divided by 16, to the nearest two decimal places is 3.31. Two decimal places. So next is to get the mole ratio. Mole ratio. Mole ratio, we divide the smallest. So between 1.6 and 3.3, this is smallest. So we divide 1.6, we divide 1.68. That means 1.68 over 1.68, which will give you 3.31 over 1.68. This will give you how much? 3.31 divided by 1.68 give you 1.9. So if we round off to the nearest, 1.9 will come to 2. So that means we'll have SI or 2. As simple as like that. So what you have to know, first you write the elements, then you go to the percentage composition, then you go to the molar mass, the number of moles, the mole ratio. Now I want to do the second part, is molecular formula. Molecular formula. Empirical formula into N will give us the molecular formula. But how do you get the N? First, you have to raise this empirical formula into N by the molecular mass. After you raise the molecular mass, then you divide with N. You get the number of N. Then that N multiplied by empirical formula will give you the molecular formula. So let's have here an example so that you know how we calculate the molecular formula. So here under heading is molecular formula. So here we are told a hydrocarbon was found to contain 92.3% carbon, and the remaining is hydrogen. If it is molecular mass is 78. If it is molecular mass 78, determine it is molecular formula. We are told C is equal to 12, height give us 1. You see, a hydrocarbon was found to contain 92.3% carbon and the remaining is hydrogen. If its molecular mass is 78, determine the molecular formula. For us to know the molecular formula, you calculate first the empirical formula. First, you calculate the empirical formula. So the same procedure. We have the element. Element here we have is carbon. We also have hydrogen. We are told carbon. Now we write the percentage composition. Carbon is 92.3. For us to get hydrogen, we take 100 minus 92.3, get 7.7. Then we write the molar mass. For carbon is 12, for hydrogen is 1. This is given in the question. Then we get the number of moles. Remember, number of moles is the mass over the molar mass. For this is 92.3 divided by 12. For this is 7.7 divided by 1. So if 92.3 divided by 12, to one decimal place is 7.7. This will also give 7.7. So we get the mole ratio. Mole ratio 7.7 over 7.7, 7.7 divided by 7.7. So this is 1 to 1. That means our empirical formula is CH. There's no need of writing 1 1. Still, there's no difference. Now we have the empirical formula. So we say, we take the mass of empirical formula, we equate the molecular mass. Say, mass of EMF into N should equal molecular mass. Mass of EMF into N should equal to molecular mass. Remember, our molecular mass is 78. Here we have 78. The empirical formula, the mass, empirical formula is CH. Our empirical formula is, our EMF is CH. Now, carbon is 12, H is 1. So we take 12 plus 1. This gives us 13. Now, the mass of the empirical formula is 13. Now, that 13 we multiply by N, then we equate to the molecular mass. That comes to 13 N is equal to 78. Now we get the value for N by dividing with 13 and 13. So we take 13N over 13 to equal to 78 over 13. N is 78 divided by 13. N is 6. Now remember we said molecular formula EMF into N will give us the molecular formula. So we already have the EMF is 6, CH. Then we know the N is 6. We bracket it with 6. This will give us the molecular formula, which is C6H6. As simple as like that. We equate the mass of the empirical formula to the mass of the molecular mass. Empirical formula 13, remember it was CH. Carbon is 12 and hydrogen is 1. 12 plus 1 will give us 13. Then 13 by multiplied by N should equal to the molecular mass. For us to get the value for N, multiply by 13. So N will be 6. Then that 6 will be multiplied by the empirical formula for us to get the molecular formula. I hope you understand. So I want to summarize this class. Remember, next time, we want to focus on titrations, concentrations. For us to focus that, I want to give brief formulas so that will help us to know, will help us to understand in the next class. So, ways of getting moles. There are 3 ways of getting moles. 3 ways. Moles. From 1 is the one we have learned today. That mole is equal to mass over molar mass, or RFM. This is all today. The other way we can get moles is moles is equal to molarity times volume over 1,000. This is the second way of getting moles. The last way of getting moles is through moles ratio. So you have to know all these 3, because next time we're going to write an equation, we see how we calculate. So you look which one is effective. If you have the mass, then you can take the mass over the molar mass. if you don't have the mass, but you have the molarity and the volume, then you can use this. But if these two is not possible, then you have to write the equations. First, for the equation, you will give the mole ratio, you will get the moles. So these are the only three ways of getting moles. I want to do the same for molarity. 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 Molarity, there are two ways of getting molarity. Molarity, the first way is gram per liter over RFM. RFM. The second way is molarity is equal to moles multiplied by 1,000, we divide with volume. So these are the only two ways of getting molarity. And these are the three ways of getting moles. I hope you have understand. So next time we want to see more of this. We want to see which way are we getting moles. We'll have a question, which will have an equation, which will have mass, which will have mole ratio. So that will focus on next class. For today, my aim focus was to get the empirical formula and the molecular formula. I hope you understand how to get the EMF and the molecular formula. So next time we look at concentrations, titrations, and more calculations on moles. I hope you enjoy and also you understand the class. This is me, Deko Mohammed. I still remind you, if you are not subscribed, please subscribe, like, and share for you to get more free lessons. That is the end. May God bless you.